back to your favorite Algebra 2 course, Intermediate Algebra. It looks like we're going to look at properties of logarithms today. So we're going to use some properties of logarithms. We're going to use them to condense, to expand, and then we're going to use a change of base formula at the end for logarithms, okay? So we can change any logarithm to any base that we'd like. So let's take a look here. Here's the first three properties of logarithms, okay? So if you got b, u, and v, and they're positive real numbers such that b is not equal to 1, you have this product property, okay? So log base u times v, okay, this is considered log base u times v is the same as log base b of u plus a log base b of v, okay? So, and then you got your quotient property, you can see it there, log base b of u over v, log base b of u minus log base b of v, and then you got your power property. You notice how that n goes down in front, okay, on the power property there, okay. So let's do an example here. Let's say we have let's say that we know log base 3 of 4 is equal to 1.262 approximately. Log base 3 of 5 is equal to that. So part A there. Let's go log base 3 of 4 over 5. So what we're going to want to do is we're going to use that quotient property first of all. Okay, you see the quotient property there? So we're going to rewrite this. We're going to expand this as log base 3 of 4 minus log base 3 of 5. And you notice that we know log base 3 of 4 is 1.262, and we know log base 3 of 5 is 1.465. So we take that one minus the other one, we get negative 0.203. Okay. Now, log base 3 of 20, we're like, well, I don't know what log base 3 of 20 is, but I do know I do have log base 3 of 4 and I have log base 3 of 5. So maybe I can write this as a product. I can write 20 as the product of 4 times 5, right? Isn't that 20? Now I'm going to use that product property. So I expand this using that property up above there. And then I substitute log base 3 of 4 is 1.262 approximately. Log base 3 of 5 is also given 1.465. And then I add those two together and I get 2.727. Okay. Finally, log base 3 of 16. Again, we're not given log base 3 of 16, but I could write that as 4 squared, right? 4 squared 16. Now I'm going to run that power property, so I can put that in front. So this is the same as 2 times log base 3 of 4. And we know log base 3 of 4 is 1.262. And then we go 2 times 1.262 is 2.524. Okay, so that's a little bit with your properties here. We're going to continue on with some more examples with expanding logarithmic expressions. So let's see if we just keep it with some variables now. So let's expand the following. Okay, log base 4 of x squared over 3y cubed. So if we're going to expand that, the first thing we want to do is you say, oh, I got this quotient right here. So let's expand this as log base 4 of x squared, and you got a minus between here, and then you got log base 4 of 3y cubed. Okay. Now you see that 2 on the x squared, so that's going to go in front. So you got 2 log base 4 of x. Okay. Now you notice right here on this 3y cubed, you notice that it's 3 times y cubed, right? So you got this product. So we're going to use that product property, and it's going to be for this whole, we're subtracting the entire expansion here. So we have to think about log base 4 of 3 plus log base 4 of y cubed. You see how we expanded the product right there? Okay, using that product property. Whoops. Sorry. Base 4y cubed. Okay, and you notice I put that in brackets so that I wouldn't forget that minus pertains to both terms there. Okay, That minus pertains to the entire log base 4 3y cubed, which we expanded. Okay. Now you notice the y cubed on this, so that's going to go down in front. Okay, we're going to expand that one. So now we got 2 log base 4 of x minus log base 4 3 plus 3 log base 4y. Now we're going to go ahead and distribute that minus through. There it is. Okay, completely expanded there. Let's do another one. Let's expand log base 6 of 9x cubed over 2y squared. That's a good one. So we're going to run that quotient property initially because we have a quotient here. So log base 6 of 9x cubed minus log base 6 of 2y squared. We put the minus between them because it was the quotient property, right? Now you notice I got a product there, 9x cubed, 9 times x cubed, right? And over here you notice 2y squared, 2 times y squared. So I'm going to run the product property on each of those to expand them. So log 6 of 9 plus log 6 of that x cubed, right? Minus, now let me do the log base 6 of 2y squared. Log base 6 of 2 plus log base 6 of that y squared. Okay? Again, don't forget you got to put those brackets around those because you're subtracting that entire term, which we expanded that term. Okay, so we gotta take that subtraction to both of those after we've expanded it. Okay. Now we're gonna run the power property. See the cube there? We're gonna put that 2 in front over there as well. So we got log base 6 of 9 plus 3 log base 6 of x, and then we got minus log base 6 of 2. I'm going to distribute the minus at the same time. Minus 2 log base 6 of y. Okay, there it is, expanded. All right, let's do some condensing. Let's go the other way. Let's condense the following. Let's say we got log of 3 plus 3 log 2 minus log 6. Minus log 6. Okay. Now you notice there's no base on this, right? So it's assumed to be base 10, the common log. Okay. All right. You notice the 3 there in front. Why don't we do the power property there first? So we got log 3 plus log 2 cubed. Okay. Of course, 2 cubed is 8. Okay. Now let's do these ones left to right. Okay. So I got a plus between them. So I'm going to say, oh, that's the product property. So log of 3 times 8. All right, put those together. Okay, so I got log 24 minus the log of 6. And you notice I got a minus between those two. So I say log of, and this is the quotient property, 24 over 6, which is 4. So I simplify it if I can. All right, log base 10 of 4. Let's do another one here. How about, let's condense this as well. 4 log base 3 of x minus 3 log base 3 of y. Okay, let's use the power property here first. So that's going to go up. Let's take that 3 up right there. Log base 3 of x to the 4th minus log base 3 of y cubed. And now you notice the minus between them. So log base 3 of x to the 4th over y cubed. Okay. Now notice on all these expansions and condense, our bases were the same. So our bases, if you're looking back at this, okay, on all these properties, our bases had to be the same, right? See that there? Our bases were the same here. Okay, so don't Don't forget that the bases have to be the same to do that. Okay. All right. Now, if you remember last time we talked about on your calculator, you only have a base 10 button on those basic scientific calculators, right? That log key is for a base 10. So this change of base formula will help you to punch in some things with a different base other than base 10, okay? So here's a formula. Log base C of u is the same as log base B, and you can pick B to be anything of u over C, okay? And in particular, and I wrote that because log base C of u is oftentimes written as a common log, so log of u over log of C, or maybe you're using it with the natural log, okay? So maybe if you see an example here, kind of be a little more clear. Let's go with like log base 5 of 6. So log base 5 of 6 can be written and typed into a basic scientific calculator as the following. So let's change it to base 10. So I could go log base 10 of 6 over log base 10 of 5. All right, and it's base 10, so I don't need to write it. Okay, which would be, and then you can punch that in that way. So log base 10 of 6 is 0.7782. Log base 10 of 5 is 0.699. You divide those two, you get 1.113 approximately. Okay? Let's do it to, let's change this to base E. So let's go log base E of 6 over log base E of 5. Of course, log base E is the same as the natural log, isn't it? So this can also be written, log base 5 of 6 is the exact same thing as the ln of 6 over the ln of 5. Well, the ln of 6 is 1.7918. The ln of 5 is 1.6094. So this also gives you 1.113. Should, right? It better, because it's still log base 5 of 6. Okay, so log base 5 of 6 is, and again, let's do, we'll do one more with log base 5 of 6. Let's do, you could change it to base 7. Log base 7 of 6 over log base 7 of 5. I know you don't have a log base 7 key in your calculator, but on some calculators you do. Let me punch that in on a TI-89 here. This is 0.921. That's 0.827. So that'll give you 1.113. Okay. Now, if you're punching this in, by the way, on a calculator, you could type it in straight from here. If you have a TI-89, okay, we have a set of here in class, how you punch that in is you go to your catalog key, and you'll see a log with a parenthesis there. And you say log 6, comma, and then you tell it what base. And that'll give you the 1.113, okay? So this is the base, actually. That's the base. So you're taking the log of 6 with base 5. Okay? So if you were doing like another one, I don't know, log base 7 of 9 on the TI-89, you'd go log 9, comma 7, and you hit enter. Okay, and it spit it out for you. All right, thank you. We'll see you guys in class.